And here we are live. Hey guys, good evening everyone. Welcome back to Coders Arcade. This is Ashang David and welcome back to our session number 21. I know we are late a little bit, but I had a class before, so I was a little bit late, but I'll try to come at time from tomorrow's class, but don't worry about it. Let us continue our class and we'll finish up today's concept. So let us start again guys for today with a fresh start. Let us understand the session 21 of this DSA live series for placement. So before I start with this, I would like to request you people to please like, share and subscribe to our channel Coders Arcade, and don't forget to press the bell icon also so that you won't miss any future updates. Let us start now without any interruption. Also, one more thing before I start with this is that you need to share this. Please share this live stream to as many people as possible who are really interested in learning DSA, because with your help and support only we are motivated to create such content, and we are able to do it with our all hearts into it. So let's start guys. Without any further ado, let's get right into the topic. So guys, in the yesterday's class, in the last class, in the previous session, I have told you about how binary search tree would work. Binary search tree, we were doing it. Now also one more thing before I go ahead into this, I have updated all the previous sessions link of the whiteboards, like all the notes. Previously so many comments were coming up that the proper notes are not given, but now the notes are also given. Probably by tomorrow I will update all the codes also for each of the video as well. So stay tuned for that guys, and let us continue right there in the today's concept, today's topic. Alright guys, so let us start. So we were doing what we were doing? We were doing binary search tree. We were doing binary search tree, BST. We were doing BST. Okay. Now in BST we have understood. In the BST we have understood our insert, we have understood our search, and finally today we all are here to study about how to delete. This is the main concept for today's class. So let us dive right into the concept. This is the code which we were doing. This was the code which we were doing, and you can see that we have done the class node already, we have done it. Then we have done the binary search tree class, that is BST class. In the private section of the class we have created the node root insert recursively function. This is the helper function. I have already explained this in the previous one. This is search recursively function, and in order DFS, and this is BFS, that I'll tell you later on. You already know by the way how to do it. This is the delete recursively function. This is what we are going to actually study today. Okay, and this was the public section of the class where we had insert, search, remove, the main functions which were getting actually called. You got my point? And these are the rest of the functions, and this is the main function ultimately, hence getting the result. Let us go back to our public section of the class and look at this function right here. We have void remove. In the void remove function we are passing one key of course which you want to remove. You want to remove a key. So how do we remove the key? We remove the key by calling this function remove, and we will put the key. That will update the new root and deletion will happen. So at the root, because root was null in the beginning, we inserted it, updated the inserted nodes into the root. We searched and it returned that search value. Now again if I want to delete something, I would have done again in the same binary tree and for that reason we are updating it back to the root. Calling the delete rec function, which is the helper function for this remove function, which is write this. Let us discuss about this, guys. So I'll take you towards whiteboard, and today when we are doing this, I will show you how you can take it. So guys, we have, imagine our BST. Let's say our BST is, this is 100, and on the left hand side you have, let's say 50. On the right hand side you have, let's say 150. On the right hand side you have, on the left hand side you have, let's say 30. This is 70. This is 130. This is 170. Okay. Let's say this guy is, if this is 130, this is going to be 110 for example, and this is gonna be 145, something like that. Okay. So let's say this is our tree. This is our BST, and I want to delete a particular element from this. I will make a copy of this so that I can later on use it for our own purpose. I will make a copy, okay, and I will use it later on. So now you see here, guys, let us say I want to delete 50. Okay, I want to delete 50. Let us say one thing, before I go ahead and do anything here, let us say that I want to delete any element here. How would you delete any element here? Let us say on the first element, this 100 only itself you want to delete. Let's say you want to delete this 100 itself. How would you delete this 100? Of course, you will pass a key. The key value would be 100, and you will pass the current root from where the delete recursively function will start. Understood? Say suppose there is a function called as delete. You are giving the delete function the key, and key is 100. Okay, delete function, where it will start from? It will start from the root only, no? And the key is itself 100, and if the key is itself 100, root is also 100, so directly root will be removed. That means this only will get removed in this case, right? Idea is we need to remove the element, but the problem is how do we get to that element? Just now we have finished the search element, search function, right? We can write the same search logic to recursively reach that particular element, and once we have reached that particular element, we can write the logic for delete. How to write the logic for delete? We will discuss this in today's class, so make sure you stay tuned to the end of this live stream. Okay, let us go here and let us paste it. Paste the same tree which I have created. Okay guys, so let us say I want to delete it. What I need to delete? I need to delete, let's say 130 maybe. I want to delete 130, I said. I want to delete this 130. How do I delete that 130? I'll tell you. Let us say, I hope so that screen is not, it is not too much bright, right? I hope so that this is visible. My stream is not too much bright, but my stream is visible. Alright, it is visible. Okay, so guys, let us say I want to delete this 130. How do I delete this 130? First I need to search that 130. How do I search that 130? Apply the search logic, the same search logic. Okay, how do I reach there? The code is already written for the search recursively function. Right here, this is the search recursively function. If the root is equals to null, in this case the root is not equals to null, so directly go here. If the root itself is the key, is the root if itself is the key, that means if 100 itself is the value that needs to get deleted, in that case return true. Rather than returning true, you will go to the deletion logic. Are you getting my point, what I am trying to say? Rest everything will be same here. Rather than returning true, here we were returning true because the function was searched recursively returning bool. But in the case of delete function, we will not return true, but we will write the logic for deletion there. If the root key is found, are you getting my point, guys? Apart from that, if the root is not the key, in that case go to roots left. If the key is lesser than the root, then go towards its left and then call this function again and keep doing this until you found the root itself as the key. In the case of this, if I want to delete this 130, Mahesh, hi sir, hi Mahesh, let's continue the class. So let's say I want to delete 130. Now to delete 130, I would have started it from the root. What is the root? Root is this. R for root. I said this is the root. Okay. I said this is the root. Now I started from here. Your key value is 130 and current root value is 100. Current root value is 100. How do I search that 130? If I want to search that 130, I will say check if root itself, if the root's key itself is equals to the key. If the root's key itself is equals to the key, and if this is the case, then what do? You directly delete it. You write the logic for deleting it, but this is not your key. This is not your key. So what do? You compare. If the key which you want to search for is lesser than the root of key. The root of key. If the key 130 is lesser than 100, that is not true. That is not true. Check if the key which is 130 is greater than the root of key. Means check if 130 is greater than this 100. Yes, it is. If that is the case, then what do? You go towards the right and make this as the new root. That means you recall the search function. You recall the search function and then make the new root as this. Now this root is now deleted. Now this is not the root. Now root is updated to that. And key is still, root is now 150, key is still 130. Are you getting my point, guys? Now you call the same function again. Check if the root key which is 130 is equals to 150. No. So go here. Check if key is lesser than, key is 130. Is it lesser than the root's key, that is 150? Yes. So go on to the left hand side. So you came right here and make this as the new root. This as the new root itself. So this root is now deleted and the root is updated back to 130, new root. Are you getting my point, guys? And there you go. Now you call the same function again recursively and you say check if the root which is 130, root key 130 is equals to the key 130. Yes, yes, you have found the 130. You have found the 130. You have found the 130. You got my point? That means you are right here standing at the correct location. Understood? So this is what we have written here. We have started. Let's go back to the delete recursively function. Here we are passing a root, we are passing key. Ultimately the root is 100, the first root. Then our key is 130, for example, 130, okay. If root is equals to null, then return that root itself. That means return that is only, nothing. Understood my point? Check if key is lesser than the root key or not. Check if the key, which is 130, is lesser than the key itself or not. Is 130 lesser than 100? No. That means don't do this. I'll tell you. I'll mark up the code and I'll show it to you. Yes sir, understood. Okay. So now let us say the root is 100 and the key value is 130. Okay. And now you see, now key which is 130 lesser than the root key is 100. Is it true? No, it is not true. So directly jump here. Okay, directly jump here and then check again if 130 is greater than 100. Yes, this is true. So go to the roots, right, and then call the same function again. Call the same function again and call the same function again. Update the root value to its right, that is 150. Now the new root has become 150. Root has become 150 and the key is still 130. So now this has been fully updated again. So in this case, check if this key which is 130 is lesser than root key which is 150. Correct? Yes. Then go inside and go to the left hand side of the root which is from 150 to the left and then call the same function again. So from here only call the same function again with the new root value as 130. You got my point, guys? So new root value is 130 now. Understood? You got this, guys? Now check, again you check if key is 130 is lesser than root key is 130. If 130 is lesser than 130, no, it is same. So it is no. So don't execute this, directly jump over here. Okay. Else if root key, which the key, this is 130, is it greater than the root key 130? No, it is equivalent. 130 is not greater than 130. So don't execute this, jump here in the else part. Else part is the place where you found the node to be deleted. Understood the logic? How smartly we have handled this situation in delete function. How did we reach till that delete function? You have understood this really well. This is very clever type of code which we have written. Isn't this clever, guys? The key here is that if the key does not match or key is not compared in this case, keep on doing until the key is matched with the root key, and as soon as you found the root key, that means the node to be deleted is found. So rather than we modified the search code and rather than writing if key value is equals to root key, rather than that we took the whole situation in the else and we rather than returning true, we will write the logic how to delete that. I hope so that this is very, very, very much clear to all of you. Got it? Okay. Okay, guys. Now we will move on. Node to be deleted is found. I hope so that this searching function has been understood. Now, guys, it is not as simple as like that. What you see right here is not as simple as that. You see, we need to delete this 130. Congratulations, you have found 130. The element which you want to delete is present in the tree. But the problem here is that you cannot delete it directly. You cannot delete it directly, guys. Why? See here why. Guys, you want to delete this guy. Correct? You cannot delete this guy directly. Why? Because it has two children. Because it has two children nodes. Are you only think if somebody has 2 children, you cannot remove that person from the post. Otherwise, the children, where they will go? Are you getting my point, what I am trying to say? This 130 is parent of 110 and 145. You cannot remove 130 because otherwise these 2 children will be lost, or this whole tree will be affected, this whole tree will be deleted. You just can't say 130 to be deleted directly like that. I hope so that the consequences you have understood this really well. Understood? Problem with this is that once you have found that the node to be deleted, you just can't delete it directly. You need to understand who can be the successor of it, so that it maintains the property of BST. Guys, maintaining the property of BST is very important here. If you don't maintain the property of BST, then it will not be a BST and deletion will not be correct. And we need to do a correct deletion, and for that we need proper deletion. So we need to think for 2 cases, guys. One, when you are going to delete a node with either a 0 child or 1 child, either 0 child or 1 child, and the case 2 will consist of when the node has, let us say 2 children. Okay, what I mean to say, for example, here is that tree. Okay, here is that tree. In this tree, suppose imagine, suppose in this tree you wanted to delete this element 130. You see that it has 2 children. You cannot delete this directly. Otherwise, what will happen? These 2 guys will be orphaned. Mahesh, after deletion 145, okay, 170 को ज्वाइन होगा क्या? 170 को ज्वाइन होगा क्या? नहीं महेश, अभी गलत हो जाएगा आपका लॉजिक. ऐसे अगर आप सोचोगे तो गलत होगा लॉजिक, वो एकदम गलत है. मैं आपको बताता हूँ कि कैसे होता है. देखो, जब भी हम लोग कुछ भी डिलीट कर देना तो हम लोग उसको डायरेक्टली डिलीट नहीं कर सकते हैं. क्यों डिलीट नहीं कर सकते? क्योंकि उसकी देखो, उसके यहाँ पे 2 बच्चे बैठे हुए हैं, लेफ्ट में एक बच्चा है और राइट में एक बच्चा है. अगर आप इसको डिलीट कर दोगे तो दोनों बच्चे टूट जाएंगे, है ना. तो आपको क्या करना है, वहाँ पे इन दोनों में से किसी एक को सक्सेसर चूज करना पड़ेगा. यू नीड टू फाइंड द सक्सेसर ऑफ दैट नोड दैट नीड्स टू बी डिलीटेड फर्स्ट. नाउ 170 इज नॉट द सक्सेसर, 170 सक्सेसर नहीं है. तो आप नहीं कह सकते कि 170 के नीचे जाएगा या 140 ऊपर जाएगा, 170 नीचे चला जाएगा. ऐसे नहीं कर सकते आप. यू कैन नॉट ऑल्टर एनी अदर डेप्थ और एनी अदर ब्रांच ऑफ द ट्री. Understood? I hope so that this doubt is very much clear for you, Mahesh. Okay, so you cannot just take up any other node from any other branch and put it over there, because it is not possible. Imagine if you wanted to do 170, you had to write a different traversal function for it, so that it traverses it and then you put it in. But that's a very difficult task. So rather than doing that, I'll tell you, there are 2 cases, guys. Case 1. Once again, guys, my camera is about to get shut down. I'll just refresh it. Right, I'm back. So my camera would have been shut it down if I have not pressed a button right there. So now, yeah, let's continue. So case 1. Case 1 is when node to be deleted has node with 1 or 0 child. 1 or 0 child. 1 or 0 child. This is important here. Case 1. For example, a node has only 1 child. For example, you want to delete this 1/3. Okay, not good example. Let us say you want to delete, I have one more node here. Let us say this is going to be 10. Let us say you want to delete this node or maybe this node, either this node or this node. Let us say you want to delete this node or this node. This node is having one child and this node is not having any child. For that the logic will be different. For that the logic will be different. So this is gonna be used for, so this is gonna be case 1. Okay, this is gonna be case 1. Alright guys, what I am trying to say, you have understood this? Case 1 for these kind of situation. Now there will be another case, case 2, where you will be handling node with, because you have already covered for 1 or 0 child, now you will cover for node with 2 children. Node with 2 children. Okay, node with 2 children. So here that case is gonna be handled for the red one. This red case is gonna be handled in case 2 and the green case is gonna be handled with case 1. So these are the 2 cases. These are the 2 cases. Ramesh, hi Ramesh. Okay, so case 1, where a node which needs to be deleted is having either 0 or 1 node as the child. The node which needs to be deleted is having either 0 or 1 child. And the case 2, if the node which needs to be deleted is having 2 children. So these are the 2 cases which we need to take care of. Let us see how we can take care of this. Okay, let us see the first case. Let us see case 1. Let us see case 1. Okay, let's say case 1, node with 0 or 1 child. In that case, what you will do? As a JavaScript developer, which language is best for DSA? It's up to you. If you are comfortable in Java, you do Java with Java in DSA. If you are comfortable with C++, you do DSA with C++. It is totally up to you. Now, if you like JavaScript, then probably you might know a little bit of Java also. And if you like Java, then you can go ahead and do it in Java. There's no point of doing DSA in JavaScript because most of the time the companies won't ask you DSA in JavaScript. Rather, companies they do ask DSA in Java, C, C++ or Python. These are the 4 languages which you should know in terms of DSA, or you should be prepared in either of these 4 languages. Understood this, Ramesh? Let's continue. Okay, so let's say case 1, node with 0 or 1 child. 0 or 1 child. So see guys, say for example, let us see this. I'll add one more thing here, that is this 10, right? So this is our tree and I want to delete this node. I want to delete this node. It has 1 child. It has 1 child. Or I want to delete this 17. It has no child. It has no child. See how I will do. See how I will do. If I want to delete this node, what I will do? I will say save this node. I'll say I will save the left node. I said save this. Save this and replace it with the 30, node 30. Are you getting my point? That means this guy only will come right here and the job is done. We node, the only child will become the successor of its parent, which is going to get deleted. This is very easy. Or in the case, I'll write here. For one child, make that child the successor of its parent and delete the parent node. Understood? This is the case for one child, for one child. If this is the case, then just make this as null itself. And when you do this, what happens? This only itself will get deleted. Are you getting my point? Understood this? Okay. So for 0 child, just make parent as null. I hope so that this is really very much clear to all of you. Alright guys. So this is the case for it. Let us see the code for it. Okay. So case 1, no child or one child. Okay guys, as I told you, if the node is having only one child, that one child could be either on the left hand side or it can be right hand side. You see, in the case for this, in this case, you see that this 30 had 10 on its left side, but it can be possible that this 30 can have this 10 on its right side. And if that is the case, then in that case, how would you write the code? We can check if the root left is null. If the root left is null, if the root's left is null, that means right child is present. Are you getting my point? Right child is present. So we took node star temp, we took a temporary pointer and we stored the roots right. If root left is null, then we stored the root right in the temp and we dynamically deleted that root. Are you getting my point? So what I have done is, if root left is null, in this case root left is not null, but root right is null. If root right is null, then save root left. Root left you saved it, okay, into temp, and you deleted this, deleted 30, deleted the 30, deleted the 30. And when you deleted the 30, what you did next is return the temp, return this 10, return the child, return the child. And when you return this child, where it goes? This returned child will go into the void remove in the public. That returned left child will be returned back to root, and root is what? The element which got deleted just now, which is 30. So by this 30 memory was deleted, but root was here. 1 second guys, my camera got shut down. Yeah, here we are again. So you got my point, what I am trying to say. We returned this 10. Now 30 was dynamically deallocated, so but the root was here only. So at the root we returned this 10, which means 10 came right here, and this 30 got deleted. In place of 30 we allocated the memory for 10. Understood this guys? I hope so that this is really very much clear. So 10 will automatically go up there. Simple step. Check if root left or right is null, respectively store the other child and return that other child and delete the root itself. That is the case for having only 0 child or 1 child. Hello Ronnie Place, Narsipuram, Sai Umar Shankar. Could you please speed up a little? Don't take it wrong. My intention is not, you can cover more concept. Yes, I'm trying my best to cover as much as possible, and I hope so that you are understanding the concepts also. I want to maintain the quality also while maintaining the speed as well. So, I am trying my best, but that is why I have stopped writing it live. I have started just showing you the codes and rather than writing the code live. So, that is the reason behind it, but let us see how we are progressing it. My target is to finish this by this month. So, if you are in sync with me, you will be able to finish the whole DSA by this month. My target is going to be to finish this whole course by this month, the end of this month. Okay. Yes. So, I hope so that other things are already clear to all of you. Well, this is how you are deleting it. Now, this same logic will work for child with no, the root with no child, Same logic will work. For example, in this case you want to delete this 145, Now this 145, you will check if its left child is null or if its right child is null. If its left child is null, then you save the right child. This is what we have done. But right child here is null. So null gets stored into the temp, and that null is returned back to the root, and root gets deallocated, and when the root gets deallocated, null is put onto that particular thing, which means this works for both for 0 child or 1 child. I hope so that this concept is really very much clear to all of you. This is the most important concept in binary search tree, where most of the people get confused a lot. Correct. So this is how you do it for case 1. Now let us move for case 2. Guys, I hope so that it is very much clear. You can ask any doubts. I can have the screen right up in front of me and I can see your comments as well. Okay guys. So this is for case 1. Let us do case 2. Let us do case 2. Now in this case, this is our case 2. Let's say I want to delete this 130. It has 2 children. Okay. Case 2. Case 2. Node with 2 children. You want to delete a node with 2 children, for example 130. You want to delete this 130. How would you delete this 130? 130 can be deleted like this. First find its successor, guys. First find its successor. How to find the successor? What you need to do is, first if you want to delete 130, how do you delete it? First find the successor. Find whose successor? 130 successor. Who will succeed him into this place while maintaining the BST property. What does the BST property says? That the smaller elements on the left and larger elements on the right. So we need to find its successor and we need to replace it with its successor, maintaining the BST property. This is how you will delete the node with multiple child or 2 children. Okay. Second, how do you find the successor? You have to find, how do you find this successor? Who is the successor, by the way? Who is the successor? The successor is always the in order successor. Now what is this in order successor? Guys, very important concept here it is that in order, I'll write in order successor is the element which comes just after the targeted element in its in order D, F, S traversal. Guys, this is the most important part of today's class, which I am going to tell you now. Focus on to this, because most of the people will miss it and most of the people will never understand this. So, I want you guys, my audience, to listen to this very carefully, because this is one of the most important concept to understand here. Now, I told you 130 needs to be deleted. Now, it has 2 children. So, out of 2 children, not out of 2 children, you need to find a successor. But the successor cannot be just out of the 2 children. If you want to find the successor of 130, it is not possible that 130 or 170 itself only will be the successor. A successor, 150 successor can be 110 or 145 also, it is possible. Got my point? A grandparent's successor can be the grandchild also. This is very important for you to understand. That is why I am saying this is very confusing and you have to understand it very clearly, guys. Very important part, guys. Listen to this. Now, if you want to delete 130, you cannot just delete 130, because first of all, if you delete 130, it will distort the whole tree, whole subtree after 130. So, what you need to do is find 130's successor. And who will be the successor? The successor will be in order successor. Who is the in order successor? In order successor is the element which comes just after the targeted element in its in order traversal of the tree. What does this means? Means, guys, listen to this very carefully. While I am doing the DFS in order traversal, after 130 in that traversal, after 130, whoever will come, that will be 130's successor. Understood my point? If I do in order traversal of this tree, in that in order traversal of that tree, whoever comes just after 130 is going to be the successor with whom this 130 will get replaced with. I hope so that this is very much clear. Let us quickly do the in order traversal of this. Let us see. Let us do the in order traversal of this, guys. Okay. In order traversal. In order traversal. I will put up the button so that it doesn't get switched off. Okay, guys. Yeah. In order traversal. Let's do the in order traversal. In order traversal means left, data and right. Left, data and right. You guys, you remember, guys? Okay. So here we started from LDR, left, data, right. Go to the left, right. LDR, LDR. L will go to the left, LDR will go to the left. Okay. First access the data here, so 30, then go to the right, there is no right, then go back, so we went to the left, then we access the data, there is no right now, so we came back and now access the data 15, then go towards its right, come here, so write LDR, there is no left, there is data and there is no right, so 70 came, and then I came back here, access the data, next data is 100, then I went to the right side, right here, LDR, say left, we went to here, LDR, I said go towards left, I went to this LDR, so there is no left, access the data, that means access 110, then go towards its right, there is no right, come back, access the data, 130 came here. This is our target element, guys. This is our target element, guys. 130 needs to be deleted. So our target element is 130 in this traversal order till now 30, 50, 70, 30, 50, 70, 100, 110, and now we are at the target element 130. Guys, whatever element comes after this 130 will be its in order successor. I hope so that this is really very much clear to all of you. Okay, so 130, 130, 130, 130, 130, and I said after this go towards its right, go towards its right. So who is next in the right? 145 is in the right. So 145. Here LDR, of course, LDR, okay, access the data, came back. So R is also done, it will go back. After this, it will go towards 150 and it will go towards 170, guys. This is the in-order traversal. See, this is the in-order traversal, okay, of this tree, This is the in-order traversal of this tree, okay. This is the targeted element 130. Who is coming just next after it? In the in-order traversal, who is coming next? 145 is coming next. This guy is going to be our in order successor for in order successor, and have to write it properly, successor of 130. This is the in order successor of 130. Guys, this is how you find the in order successor of that element. I hope so that this is really very much clear to all of you. Understood? This is the long way method, but don't worry, I'll teach you the shortcut method also. Don't worry about it, I'll teach you the shortcut method also. Listen to this. Again, what I've done. How to delete that 130? First find its successor. Who will be the successor? In order successor. Who is the in order successor? In order successor is the element which comes just after the targeted element in the in order traversal of that tree. Okay. Yes, 145 will be the new root. Correct Mahesh. Okay. In this case, we did the in order traversal to find 130 successor. Okay. So here in order traversal was LDR. That means to do in order traversal, this was our in order traversal of this tree. And after 130 in the targeted element, who came next? 145. This guy is the in order successor of 130. That means we have now found the successor. Now what do? Replace that with the successor. Replace this successor with its new root. So the new root will become, as Mahesh said, 145, and 145 will go here and 130 will be deleted. 145 will take the position for this 130, and this will maintain the order of BST. It will maintain the property of BST. Hence, nothing will be wrong. Everything is in harmony. Everything is in peace. Alright guys, I hope so that this is really much clear. Very important concept of today's class was this only, guys. This is the reason why I did not take this concept in yesterday's class. I wanted to solve this in today's class. Hope so this is clear to all of you. Whoever is watching right now is clear to all of you. Okay guys. Now this was the long cut method. Now I will show you the shortcut method. What is the shortcut method, guys? Okay, after this step, replace that successor with the targeted element. Hence deleting the targeted element successfully. You got my point? This is the third step of doing all these things. This is how you delete it for the case 2, guys. Okay, alright guys. Okay. But this is fine, this is okay. Now what is the shortcut method, guys? Shortcut method. Shortcut method. Shortcut method. Time for the shortcut method. I wanted to explain this long cut method because I don't want you to directly jump to the shortcut. Understand the logic first, so that in future, even if you have forgotten the shortcut, you know the roots, the base, so that you can only navigate on your own. Now listen to the shortcut. If you want to find the in order successor, sir, अगर 145 के दो चाइल्ड होते तो, हाँ मैं आपको बताता हूँ, अगर 45 के दो चाइल्ड होते तो आपको 45 को टारगेट एलिमेंट रखना होता और फिर उस पर आप सेम इन ऑर्डर ट्रैवर्सल कर लेते. देखो अगर 45 होता तो 45 के बाद जो भी आ रहा होता वो हो जाता उसका इन ऑर्डर सक्सेसर, है ना. देखो 45 के बाद कौन आ रहा है, 150, सो 150 हो जाता उसका इन ऑर्डर सक्सेसर. आपको समझ में आया ना मेरी बात महेश? तब इन ऑर्डर जो होता, देखो 150 गलत होगा, it will be wrong. Why? Because if 145 had two children, if 145 had two children, then the DFS order will be changed. After 145, there will be some other child only of 140. That would be the in order successor of that 140. इसको हिंदी में अगर मैं समझाऊं तो, अगर महेश आपने पूछा है कि अगर 140 के दो चाइल्ड होते तो क्या करते सर, तो मैं बताता हूं आपको. अगर 145 के दो चाइल्ड होते तो अब 145 को टारगेट एलिमेंट रखते और उसके ऊपर ट्रैवर्सल करते, तब आपका जो डीएफएस ट्रैवर्सल होता वो कुछ और अलग आता. यहां पर 145 के बाद 150 इसीलिए आ रहा है क्योंकि 145 खुद 150 का चाइल्ड है. अगर 145 के खुद के चाइल्ड होते तो यहां पर जो डीएफएस ट्रैवर्सल होता वो थोड़ा सा चेंज हो जाता और 145 के अपने अलग जो चिल्ड्रन होते वो यहां पे दिख जाते. तो 145 के बाद जो कोई भी आता वो हो जाता उसका इन ऑर्डर सक्सेसर और वो बनता वहां पर. ठीक है. हाँ, नाउ आई विल टेल यू द ट्रिक. अभी मैं आपको शॉर्टकट ट्रिक बताऊंगा जिससे कि आपका प्रोग्राम, यहां पे आपको इतनी कैलकुलेशन नहीं करनी पड़ेगी. नाउ आई विल टेल यू द ट्रिक so that you don't have to worry about doing so many calculations right here. What is the trick? Guys, I wanted to delete, let's say now I want to delete 130, right? Without doing any calculation. Without doing any calculation. I can just tell that 145 is the right successor. Sir, wait, my camera got shut down. Sir, could you trace programs with examples along with it as Kruskals, Prims, Floyd and Warshalls? Topological order, knapsack, subset, n-queens, backtracking in C language, please sir. Yes sir, समझ गया. हाँ, Chickappa YR, yes, we can do that. Yes, definitely we can do that. I'm not that good at C, but I can do it. We can do it. Together we can do it. I will try to do it. I'll make a note of it. Okay, I'll make a note of it. And yeah, I will be doing all of these, not all of these, but yeah, most of these in C++ in future, upcoming future. So if you are tuned with our channel, I will definitely come up and I'll solve some of the problems which you have mentioned here in your comment in the same YouTube channel, in the same series I will solve them. So stay tuned for that. And yeah, that's all what I want to say for this comment here from Chickappa YR. Yes, I will do it. Okay, continue, class continue. Let's continue the class, guys. Okay, so now guys, I told you this is the long cut method. Okay, now listen, I'll tell you the shortcut method. Shortcut method. Okay, shortcut method of finding in order successor. What is that? What is that? What is that? Let's continue guys. Okay, let us see that. Okay, so what I'll do is I'll use the same thing. Guys, now let us say you want to find the in order successor of 150. Guys, you want to find the in order successor of 150. You want to delete that 150. Guys, let us focus on to here. Let us finish this up. Let's say you want to delete 150. And if you want to delete 150, how would you delete 150? First you will find it. You found it. Now you want to find its in order successor. So the secret to find the in order successor is, I'll tell you. I'll write it here. In order successor will be the so this is the main concept. Leftmost leaf node. Leftmost leaf node. Leftmost leaf node on the targets right subtree. Guys, this is the secret of all. I have told you the whole secret in one line. In order successor will be the leftmost leaf node on the target's right subtree. What does it means? Guys, listen to this very carefully. The most important concept. You want to see 150 getting deleted. You want to see 150 getting deleted. Then what you will do? In its right subtree, the leftmost node, the leftmost leaf node is its successor. Now in the right subtree there is no leftmost node. So I can say the successor for 150 is 170. If I want to delete 150, the successor for 150 is 170 itself. Because 170 doesn't have any left subchild. What I'll do, I'll go to 50's right, and in the 50's right leftmost node, that means 170's leftmost node will be the successor, but there is, in this case there is no leftmost node. So 170 itself will become the successor. You have not understood this? Listen to this now. Imagine you want to okay, imagine guys, imagine not 150 but you want to delete 100. Guys, you want to delete 100. You need to find the in-order successor because it has two children. Who will be the in-order successor? Who will be the in-order successor of 100? Can you tell me? Can you tell me in the comment section? I am waiting. In the comment section, can you tell me who will be the in-order successor of 100? Hundreds leftmost leaf node in the target's right subtree. I am repeating this again. Who will be the in-order successor of 100? In-order successor of 100 will be the leftmost leaf node into the right subtree. Who is it? Who is it? Who is it? Can anybody tell me in the comment section? I am waiting to see your comment, guys. There's a Tell me guys, tell me. There is some latency in the stream, but can you tell me guys? Who can tell? What is the in-order successor of 100? In-order successor of 100 is the leftmost leaf node index 100 के लिए 110. Absolutely right, Mahesh. Right answer. Absolutely right answer, Mahesh. You have understood the concept. I hope so other people have also understood this. Absolutely correct. Congratulations, you have learned the concept of finding the in-order successor. You don't have to always do the traversal. What do you need to do? Just go to its right subtree and go to its leftmost leaf node. That is the in-order successor of the targeted element. This will solve the doubt for Mahesh for 140 has the child or not. Mahesh, आपका एक डाउट था ना 145 का अगर 2 चिल्ड्रन होते तो क्या होता? अगर उस समय अगर आप 130 को डिलीट कर रहे होते और 145 के 2 चाइल्ड होते तो 130 का सक्सेसर 145 के लेफ्ट वाला होता. अभी आपको समझ में आया महेश? हाँ कि ना? Mahesh doubt was that sir, what if while deleting 130 145 had 2 children, then what would have happened? Then if 145, let's create that scenario. Let us create that scenario. If 140 had 2 children, that is 140 and 148, then 130's successor would be 140. Are you getting my point? 130's right subtree's leftmost leaf node. That is the formula to success in deleting the nodes. Very important concept in the whole BST concept. Understood this guys really well. I hope so that this is really very much clear. Now for 100's right subtree leftmost node, this is gonna be the successor of 100. Are you getting my point guys? Everyone have understood this really well. Clear to all of you? This was the logic to delete a node from binary search tree when you have to check for 2 conditions guys, and my camera went off and we are back. This was the logic for deletion of node from a binary search tree. You have to check for 2 conditions. Case 1, condition 1, if the node has no children or 1 children. Case 2, if the node has 2 children. For 1 children, it is simple. Either of the children you will save and then you will replace the children with the parent itself. That is going to be the successor, because if the node doesn't have any child, then what do? You replace the whole targeted node with null itself. The same logic works for both 0 and 1. That 0 children or 1 children. If the targeted node has 2 children, then what do? You will say, you will say that you will find the in-order successor. Who is the in-order successor? On the target's right subtree leftmost node. On the target's right subtree leftmost node is the in-order successor, the leaf node we are talking about. And I hope so that today's concept you have understood very well. Very important code question was, and of course let us see the code for it quickly. So guys, I'll go back to the code and you see that case 1 was handled already. Now this is case 2. where case 2, how we are handling the case 2, we are saying, I'll zoom in up into this. Okay, this is case 2. Okay, so what did we do? Find the in order successor. Find min is the function which is doing the job of finding the in order successor. So you see what I have done. Find min is the function where I am passing the roots right. I am passing the roots right subtree, and that find min function is written right here. See what find min is doing. It is getting the node. Node is the targets right. सर अगर सब ट्री को ओनली राइट चाइल्ड है, सक्सेसर राइट चाइल्ड, अगर सर अगर सब ट्री को राइट चाइल्ड है तो सक्सेसर राइट चाइल्ड होगा? हाँ, सक्सेसर राइट चाइल्ड होगा. तो मैंने आपको 170 वाला एग्जांपल दिखाया ना, 170 वाला एग्जांपल आई हैव शोन यू, राइट? इफ द टारगेट्स एलिमेंट हैज ओनली वन राइट एलिमेंट, in that case 170 itself will be the successor. So in this case, if 150 is there, so the successor for 150 becomes 170. Got your doubt clear, Mahesh? Hope so that this is really very much clear. आपका doubt clear हो गया शायद? Okay. Code की तरफ चलते हैं. Let's do the code first. Okay. So this is the find minimum which is doing the job of finding the successor, and it is taking up the node, and in the node we are passing up the node the root right. So basically we are passing the roots right here, and from that we are going till the left until we reach the root node, the leftmost leaf node. I hope so that this is very much clear to all of you. Okay. Now you see here, after finding that successor is stored into the temp. The successor is stored into the temp, and once the successor is stored into the temp, you say the root key you get replaced by the temp key. Why I have done this? Rather than deleting the allocated memory to the, okay, I wanted to delete this 130, right? Rather than deallocating the memory for 130, I replaced the 130 with its roots successor. 130 got replaced by 140. The values got exchanged. Understood my point? The values got exchanged. Understood? So what I did is, I'll physically do it and show you. This 130 gets deleted. So allocation does not get deleted. Only 130 got replaced with this 140. So this is also 140, and this will also become 140. Okay, I hope so my point is very much clear. I did not delete the memory allocated to 130. 130 was there. I did not delete the allocated memory. Memory is allocated still. I just copied the content of its successor to it. Okay, and then what I will do? I will deallocate the memory for the successor. Simple. And I then, what I have done? I have done this, and what I have done on the roots right, I have called the same thing again. Okay. So now what happens? On the roots right, and my camera got, okay guys, as you can see the battery is almost over. Let me do a battery change quickly, guys. I'll be back here. In a moment I'll be back. Guys, I'm doing the battery change. So stay tuned. I'm not gone anywhere. Just changing the battery. And there we go. We are back. I hope so that we are back. Yeah, we are back. I've changed the battery. Battery is full now, and I'm back. The battery was over. Okay, guys. So I hope so it is very much clear to all of you what we have done here. We have called the same function recursively, and the element got updated. The new root is updated. Okay, guys. So this is how you do it. Chikkappa YR. Sir, because on YouTube many videos show problem solving but no one explains how each line of an algorithm program works. Can you explain how these programs run line by line with help of an example? Yes, I will do, Chikkappa YR. Why not? Why I will do. I will explain. Do not worry about it. I'll make a note of it. I'll do it. It is soon going to come next. Okay. I'm making a point of it and I will be doing that. I'm saying this in the video. We are gonna do that when the time comes for this. Okay. For C, we need to start the different process, or we can just make some videos and post for it. But in C++, of course, we are gonna do this. I will explain all the lines of code. Don't worry, like how I'm doing this here. Okay, guys. That's all, guys. I hope so that this is very much clear. Today we went off time, but this was worth it. I hope so that everyone have understood what I wanted to discuss here, what I wanted to explain here. This was the most important concept in the whole BST concept, and with this we have finished up the BST concept. Tomorrow in this class I will be just brushing up the concept what we have learnt in BST, and we will finish the DFS and BFS of BST also. There is no change, but I will just show you and give insights on BST and BFS and DFS of this binary search tree. Finish up the course for the trees, for binary search trees, and let's see what else we can do in tomorrow's class. I hope so that this is really very much clear. This is the content, and today we have done a lot of things. As you can see, we have done a lot of things. So make sure that you keep on revising the content, guys. All these notes I am giving in the comment section and the description below here. So make sure you do check out our notes link also. And guys, that's all for today's class. I hope so that this is very much clear to all of you. Do not forget, sir, आपने in order से successor find किया है, प्री ऑर्डर से किया होता तो अलग होता, तो ऑर्डर क्यू में डिफाइन होता है क्या? तो ऑर्डर क्यू में डिफाइन होती है क्या? अच्छा महेश, देखिए, कभी भी आपको सक्सेसर निकालना होता है बीएसटी के कॉन्सेप्ट में, तो आप इन ऑर्डर सक्सेसर ही निकालते हो. यही रूल है. आप प्री ऑर्डर या पोस्ट ऑर्डर सक्सेसर नहीं यूज कर सकते. आपका जो इन ऑर्डर सक्सेसर होता है वही एक्चुअल सक्सेसर होता है बीएसटी की प्रॉपर्टी मेंटेन करने के लिए. अगर आप प्री ऑर्डर का सक्सेसर निकालते हो, किसी भी टारगेट एलिमेंट का प्री ऑर्डर सक्सेसर निकालते हो, तो वो काम नहीं करेगा, वो बीएसटी की प्रॉपर्टी को मेंटेन नहीं रखेगा. हमारा मेन गोल है कि हमारा जो बीएसटी है, जो हमारा बाइनरी सर्च ट्री है, उसकी जो प्रॉपर्टी है बीएसटी की, कि सारे स्मॉल जितने भी छोटे वाले हैं वो सब लेफ्ट में जाएं और जितने भी बड़े वाले हैं वो राइट में जाएं. वो प्रॉपर्टी मेंटेन करने के लिए जो हमारा सक्सेसर होता है वो इन ऑर्डर होना चाहिए. तो इन ऑर्डर में पहले लेफ्ट आता है, फिर राइट आता है, फिर बीच में डेटा आता है ना. तो आपको इन ऑर्डर सक्सेसर ही निकालना होता है. आप वहां पर प्री ऑर्डर और पोस्ट ऑर्डर का इस्तेमाल नहीं कर सकते. फॉर दोज पीपल हु हैव नॉट अंडरस्टूड इन हिंदी, लेट मी एक्सप्लेन यू हियर व्हाट आई हैव सेड जस्ट नाउ. Mahesh 223 asked one doubt that, sir, rather than using in order successor, can't we use pre-order or post-order successor? So my answer to this is no, we cannot use pre-order or post-order successor. Why? Because it will not maintain the property of BST. It will not maintain the property of binary search tree. Understood my point? And we need to maintain the property of binary search tree. Are you getting my point, guys? Understood? So a very nice question asked by Mahesh, and the answer to this is no, we cannot use any other successor like pre or post, but yes, we only have to use in order successor to make sure that the property of BST, what does the BST property says, that all the smaller elements are kept on the left hand side of the root and all the larger element from the root are kept on the right hand side of the root. And to maintain this property, when you are deleting the element, you only can use in order successor. Alright guys, I hope so your doubt is clear. Now let's start a 5 to 10 minutes doubt session. If you have any other doubts, please let me know. I am right here to clear all your doubts. Okay sir, thank you. Okay, yes sir, clear all doubt. Okay. Thank you so much guys for attending today's class. Thank you so much guys. When you are here with me in the class, I even get motivated to keep on creating such content, and I am always motivated to train you onto these kind of things. My passion is to teach, and I am trying my level best to train the students in such a way that they can understand any concept like this very easily. So thank you guys so much. Thank you Mahesh, thank you Chikkappa, thank you Ronnie Plays, thank you a lot of people who were there in my today's live stream, and I hope so that they have understood a lot of things in today's class. Chandan Kumar we had, Ronnie Plays we had, Ramesh we had Mahesh, we had Chikkappa. Thank you guys so much. I hope so that you have liked today's stream. If you have liked and understood what I wanted to explain, thank you so much. If you have understood today's stream, please give us a like, hit the like button, and don't forget to subscribe to our channel for more updates and content like this. It motivates us when you support like this, and thank you guys so much. Ronnie Plays, sir, what about the internships? When are they going to start? Yeah, we are working still, Ronnie Plays, onto the internship part. I'll very soon post it onto a Telegram channel. So guys, listen to this very carefully. If you want any updates like internships or placement updates, please follow our Telegram channel. There I am working my level best to get internship model start running onto our channel. Internships will be provided both online and offline. So those people who want to do internships, please do let me know, and please contact us onto our company's info. You can contact us onto Telegram, you can contact us onto our company's number, which is already given in the bio of our channel. So make sure that you subscribe to our Telegram channel also. Mahesh, सर आपने लास्ट में 2 नोड ऐड किए थे, उसमें 100 का सक्सेसर 110 ही रहेगा या फिर 140 हो जाएगा? तो 100 का सक्सेसर अगर देखें, अगर हम 100 का सक्सेसर देखें, यहाँ पर आप बोल रहे हैं कि हमने 100 का सक्सेसर राइट सब ट्री में लेफ्ट मोस्ट तो 110 ही होगा, तो महेश 110 ही होगा 100 का सक्सेसर. आप देख लो, 110 को अगर आप ऊपर रखोगे तो वो प्रॉपरली 50 और 150 को मेंटेन करके रखेगा. अब 150 को एकदम से नहीं रख सकते, वो बहुत बड़ी वैल्यू हो जाएगी, है ना? तो आपको समझ में आया? महेश asked one doubt. Let me explain. Mahesh asked that, sir, what if you have at last you have added 140 and 148 as two new nodes. So what what will happen now if you want to find the in order successor of 100? To find the in order successor, of course, it will be always on the right hand subtree on the leftmost, which is still 110. So 110 only will be the successor of 100, which will be replaced by the targeted node. Okay guys, I hope so that this doubt is also very much clear for Mahesh. आपको समझ में आ गया, आपका doubt clear हो गया. Thank you guys so much. Okay, so guys, again I'm saying, do not forget to like, share and subscribe to our channel, and don't forget to press the bell icon also so that you won't miss any future updates. For more updates on internships and placements, I'm trying my level best to get you internships and placements both. I am trying my level best guys to get you towards placements and internships. So if you are interested in getting internships or placements, please stay connected and stay tuned with us. Do not forget to connect with us on Telegram channel, and where we will be posting all the updates. Telegram link is already given in the description below, so please do not forget to connect with us on Telegram. Guys, spread our Telegram link everywhere, because that is the most important part. I'll be posting today's notes with the link of the live session there on Telegram, and the link will be also given in the description below as soon as this live session ends. Thank you, sir. I understood all today. Thank you, Mahesh. It was very nice to have you in the class and help you to clear all your doubts. I hope so. Everything is clear. It's already 8:30 now. So I hope so that it's the time to end the session, and go home, and let us meet again tomorrow, guys, at the same time, 7 o'clock Indian Standard Time. I'll be back again with session number 22, where I will be again doing something with trees. By tomorrow I want to finish trees, so let us see how it goes, guys. Thank you so much for watching. I thank you so much for being with me until the end of this live stream, guys, and I hope so all your doubts were cleared. I can see there are no doubts, no other doubts here. Stay tuned, guys. Stay tuned, stay connected, and stay safe. Telegram, don't forget to connect with us on Telegram. Telegram, very important, guys. Alright, so that's all for today's session, guys. Ronnie plays about internship. I will be updating it very soon in our college group only, and our Telegram channel as well. Okay, Ronnie plays. Understood? I'll be updating you directly. So that's it for today's live session, guys. I'll be ending up the live session. And thank you, guys. I'll see you tomorrow, same time. Do not forget to come again daily, connect with us. कल कौन सा टॉपिक है? कल हम लोग ट्रीज का खत्म करेंगे, बीएफएस और डीएफएस का हम लोग खत्म करके के शायद हम लोग एक नया ट्री का कॉन्सेप्ट चालू करें. तो देखते हैं क्या करते हैं. महेश, कल मैं जब वीडियो को शेड्यूल करूंगा तो आपको पता चल जाएगा वीडियो के थंबनेल में, तो आप बेल बटन को दबा के रखिए. चलिए, okay guys, I'll be get going. It's already time. Thank you guys so much. I'm shutting down this stream. I'll see you tomorrow again back at 7 o'clock Indian Standard Time, and we'll continue with our DSA concept tomorrow. I'll be uploading the thumbnail and I'll be scheduling the live session. So on the thumbnail you can see the content. Alright guys, thank you. Bye bye. I'll see you tomorrow. Bye bye. Have a good night.